Hi everyone. Welcome to this afternoon's session, Where is Life Insurance Pricing Headed? Balancing Complexity and Granularity with Common Sense, presented by Matt Noyce and Francis Burgess. Matt is the founder of MNC and has 25 years experience in life insurance and reinsurance across Australia, New Zealand, Asia and the UK markets. Matt's previous leadership responsibilities include Chief Pricing Actuary for Swiss Re and a member of the Australian leadership team and Asia Products leadership team. Prior to that, he was the Chief Pricing Officer for ComInsure and responsible for the pricing of its life and general insurance portfolio. His technical expertise covers pricing, product design, experience studies, reserving, regulatory capital, risk management, reinsurance, and M&As. Francis is head of pricing for Zurich's group insurance business. He's an experienced old actuary, in his words, with a passion for pricing and data analytics, having held senior roles in both direct insurers and reinsurers. He has first-hand experience in introducing data analytical techniques into traditional processes and understands the challenges of explaining black boxes to senior pricing stakeholders, as well as the potential and power of these emerging techniques. I'm very excited about this session and looking forward to what Matt and Francis share with us this afternoon. I've had a few discussions with them previously on this topic, and I always get something interesting out of it. So on that note, I will pass over to Matt to start us.
Well, thanks, Kirsty. So where is life insurance pricing headed? Balancing complexity and granularity with common sense. Today, what we'd like to do is cover some of the newer style techniques in terms of pricing that are being used in life insurance. I will give you a case study, which begins by transforming an older style technique that most people would be familiar with, and basically transforming that into a newer model. We'll also consider why we should consider changing to some of the newer style models and techniques, and how we might go about it. We'll share some of the potential pitfalls that we find people might encounter along the way, and we'll ask you to vote at the end. So the modelling has been led by Francis, with assistance from two data scientists in my team, Bob Reclui and Luca Crute. And we are about to publish some of the R scripts for people to use, and that will be available for download, I think, tomorrow from the MNC website. So you can feel free to please experiment with that code and use that in your own model development. But to set the scene, first of all, it's a very exciting time of change for pricing, modeling, and data analytics within life insurance. The quality and volume that we have now of analytical techniques, computing power, and data available means that we can provide a lot more granular analysis and insights today than was historically possible in life insurance and super. I mean, in life insurance, look, it still feels, to be honest, that we're still trying to catch up with the general insurance actuaries in many ways. But, just how far can and should we go with this? So in this section, we'll compare the different schools of thought, beginning from the old style, Excel-based modeling, through to more advanced modeling and software techniques. Now, in terms of investing in the latest technical skills and tools, there are a lot of different applications now within life insurance, but we've taken group life as an example of where change is possible, perhaps desirable, and in many cases happening right now in the market. So more specifically, chain ladder in Excel is a technique and platform that many actuaries are familiar with. It's a simple technique, but nevertheless requires quite a lot of judgment, and it's now possible to rewrite it in R in quite a nice, efficient way, and apply more statistical objectivity, and then build that out into more complex and more advanced techniques. So, in terms of today's session. Francis will, in a sec, take us through the case study, which is applied to group risk IBNR and incidents, and he'll talk about the claims data that we've simulated from a real data set, and the model fitting, beginning with chain ladder in Excel and transforming into our code, and then showing that those two models are equivalent. We'll also think about what's in it for us, why should we move to newer techniques, and we'll also talk about how you might get those various stakeholders in your organization across the line and what's in it for them. And finally, we'll cover some of the pitfalls. So there are many pitfalls to be aware of when you're implementing newer techniques and models, and we'll have a bit of a light-hearted pros and cons and ask you what you think. So, over to you, Francis.
I've not done this before, but I love this little piece of kit. So if only my life could be this simple. It has a big green button to progress you to the next slide. And then if you make a mistake in your life, a little red button to get you back to where you started from. So where has this device been all my life? Now, I'm really pleased to see, I didn't think we were going to fill the room, so we've done a good job. The last one, it looked like there was some clustering modeling going on where people were sort of always going to the back. I had threatened to jump off the stage with my roving mic and go to the back, but I think there's a good dispersion here, so that's good. I almost didn't join you. If you can see from the back of the stalls, I've got a big bruise and a cut on my head. About a couple of months ago, I decided to headbutt the boot of my car. Not surprisingly, the car came off better, and I ended up sort of swearing to my wife, I think I needed head surgery, but after a couple of bandages, it was okay. On Sunday, I repeated it. I thought, let's go in for a rematch. And I headbutted the same boot of my car, and I now have a bigger bruise on the right-hand side of my head. I'm looking for best of 5 at this stage, so I almost didn't join you. Anyway, I'm going to get to use the green button. So, look, I love my job. I've been doing pricing since 1993, which means I'm definitely old. I think I've learned more about group pricing or actual pricing in the last 3 years than I have in the previous 27. And the reason for that is I'm just really enjoying data analytics coming to it. I'm not by any means an expert. I have sort of introduced it to a couple of companies. So I'm sort of experts in terms of the practitioner side of things. I'm not by any means a guru, and there's a lot more people better than I am. But I thought I wanted to share with this group and people who might be where I was back in 2018 when I was just starting on my R journey. And we will be publishing tomorrow some code. So all these pretty pictures that I'll be going through today, you can replicate and have fun yourself. Now, what I started with is a little bit of a simulated data. So just starting on our case study. So the first thing is simulated data. I love simulated data. Number of reasons for that. First and foremost, you don't get yourself into any of those sticky sort of situations with client confidentiality. But also, you know the answer. How nice is it to test your model as a group pricing actuary, knowing what the answer should be? Normally, you don't have that luxury. And also, it's great if you want to test, how good is my model dealing with a notification shock? How good is my model dealing with stratification by different cohorts? Well, you just model it, you simulate that, and you can answer the question yourself. So what this sort of presentation is, and the code that we'll be sharing with you sort of goes through, is a really simple scenario. We're looking at the idea of taking the use case of IBNR in group risk pricing, but it could really be anything. And we're looking at some sort of, taking a traditional actuarial technique which uses homogeneous groups techniques and then applying some more granular data to that. So in the sort of snippets, picture snippets of our tables behind you, you can see that what I've got in my simulated data is just 100,000, well, if you've got really good eyesight, you can, but we've got about 100,000 lives in a sort of mid-size industry fund. I've simulated 8 different age groups with different incidence rates, but most importantly, each age group has a different notification delay. So the older groups cohorts report faster, the younger cohorts repeat slower. I've simulated 20 time periods. There's a little bit of a trend. The incidence increases by 1%. But importantly, I've assumed that there's no notification shock. So there's no PYS in this simulation data. I'm just looking at the impact of age. So what you end up with is 8 different ages, 20 different time periods, and about 160 different exposure points. Now, the other thing we did next after that is to simulate a bit more claims data. So what I've got there is for each of those 160 exposure points, I will simulate, I've got expected number of claims. I'm just going to use Poisson distribution to simulate the actual claims count. But into that, I might say, look, I might expect 21 claims for this model point. I end up getting 23 or something like that. But more importantly, for each of those 23 claims that I'm generating, I'm going to actually come up with what the notification delay would be from those 23 claims. And for simplicity in the code, we've just used an exponential distribution, although in practice it's a lot more sophisticated than that. What I love about R is the ability to sort of do that sort of work in a few lines of code. So behind me, if you can squint even further, the first one up there is a single line of code that generates a whole load of grouped claims from my exposure scenario. And then there's a slightly longer piece of code, but again, not hugely taxing, that generates individual claims within that group data that have simulated dispersion of notification delay. And that notification delay, again, varies by the covariate that we've chosen. So you can see there I've got about just over 6,000 simulated claims now by exposure period, by age, and the whole thing in R takes you about 4.7 seconds. Cool. So the other thing here is this, is what I've enjoyed about my sort of data analytics journey at the end of my actuarial career, is just the ability to have great graphics, but also just learning some new concepts. So what I found in the last couple of years is there's an awful lot that actuaries can teach data scientists, but there's an awful lot that data scientists can teach actuaries. So just the whole concept of test data or training data, so use the training data to fit your model, the test data to do it. And when you're simulating data, that's all fantastically easy because, you know, the data that's in the future, for example, in my use case, turns out to be the test data. The nice little pretty chart at the bottom there is 1,000 simulations with my 300 claims every event period, slightly growing over time. And then the blue and red, the blue's at the top for those that are colorblind, is the paid claims, and the test claims is essentially the claims that are in the future in my simulated data set. So that's the IBNR that I'm trying to estimate. So what have we done in the past? So what we've done in the past, I think we started with the chain ladder. We've used it for I've used it for 20 years. I think it dates back to the 1950s, some sleepy town in Missouri, if you believe the legends. But what we've got here is just an explanation of what the claims count would be with notification day. And I've used slightly different varying shades of blue just to break it down by the ages. So if you do stand up, turn slightly to your left like a penguin, then you'll be able to see that the older ages do indeed notify quicker. Now, I do remember when I first started group pricing, we used to have very large spreadsheets, very large macros, and lots of tabs. I think it's the 20 lines of code you see there is the chain ladder in R using a package called data table. It's an extremely efficient way of writing it out, and it enables you to do things an awful lot quicker than we've done before. So just a few things here from this one. The modeling scenario we're testing here does keep to within the constraints of the chain ladder or the MAC model. It doesn't have any notification shocks by different time periods. We're just looking at the granularity here. And because of that, if you probably know quite well, if you're a group of pricing actuaries, the MAC or the chain ladder model is unbiased in that situation if the axioms hold. And in the 1,000 scenarios here, you can see that straight line is flat through 0, which tells you that it's unbiased. So it's an awful lot of effort and an awful lot of work to come up with a big fat 0, but that does make me happy. And then you can also see in the blue and green, so the blue is still at the top for those who have hard of colour sight, you'll see that there's the paid claims, and then the green is actually the IBNR. So that's my estimate of my test data from the chain ladder model. And you'll see there's an awful lot of variance in the test data, which is what we know and love from group pricing, which is that IBNR is okay to test earlier on, but later on becomes a bit of a problem. Now, look, I'm a practitioner. I'm not an academic. I would like to say that I spent 3 days after Christmas, about a year and a half ago, just reading through the monogram on the left there from Greg Taylor and Grianne McGuire. I wouldn't say it changed my life, but it did change my group pricing. I would recommend that read to any one of you that hasn't had a look at it, read it before. I absolutely enjoyed it. My wife thought I was completely mad. I spent 3 days in January 2021 up in my study reading the paper. It was a bit of a revelation. Highly recommended. But what it does do is it describes a situation where you can move away from the chain ladder heuristic or just a sort of flat algorithm to replacing that with a statistical model, in this case a generalized linear model. And that generalized linear model, I almost fell off my comfy sofa when I found out, but you can construct a GLM. I didn't know this, I've been doing group pricing for 20 years, but you can construct a GLM that gives you exactly the same result as the chain ladder, not almost there, but 6 decimal places exact, through the use of a specific set of GLM sort of constraints. And what that enables you to do is actually take starting off from that chain ladder, which you all know and love. All your pricing stakeholders will be happy and familiar with that. All your competitors will at least be benchmarking against that. And then you can at least start off in your GLM journey with a waterfall chart that doesn't move at all when you take it through your stakeholders. And then any changes you do from that GLM is a small waterfall step, and it's great for communication. The other thing I found in my time here is that the little graphic, the little sort of graphic of chain ladder cross-classification. So cross-classification is the GLM model I'm just about to describe. The other one, though, is hazard models. And I think it's really useful to sort of see that the IBNR chain ladder can be constructed either as a chain ladder or a cross-classification GLM or as a hazard model, and they're all equivalent. What is a cross-classificational GLM? If you haven't spent your January before last reading the very large, extensive monograph, essentially what it is, it's a GLM call that just has it uses the claims count in the group as the function, and it has 2 explanatory variables, notification delay and exposure period. In other words, if you think of this as a 20 by 20 square, the green triangle is the data you do know, and the white triangle is the data that's uncertain. And what you're trying to do with a GLM is estimate about 40 parameters. The alphas, as we call them, are the ones along the column there, and they represent the estimate of your ultimate claims count. And then the betas is your column. I'm going to grab some water. The betas is your column estimate. So if you think a beta is 5%, 5% of your ultimate claims fall within that column. And then you assume that it's Poisson distributed, and that GLM will give you exactly the same result as the chain ladder. I must admit, when I first found that out, I was astounded. The other thing is that looking at it from a statistical point of view, you do get an insight as to why the traditional actuarial models behave in the way you do. So you can see here in the bottom left-hand of the triangle, you're fitting a GLM to only about 20 model points. There's 200, 20 by 20 divided by 2. There's 200 data sets in the training there. You're fitting about 20 or so in that bottom left-hand corner. It's no surprise that the GLM is very, very sensitive to the data in that bottom left part of the triangle. That's what we've known using the chain ladder for 20 years, but it becomes quite easy to understand it in the context of a statistical model. Similarly, at the top right-hand side there, you've got the betas in the sort of late tail. He's got not much data. And again, this tells you what you know and love from doing a group pricing actuary, that the data comes quite sparse out there. So what's in it for us? So beautiful, very, very pretty pictures is the answer to that question. But obviously, there's a commercial aspect before that. But it enables you, as a senior pricing actuary, to communicate some of the complexity that is very, very difficult to understand in our existing models or judgment calls, and explain it to pricing stakeholders or super funds exactly what's going on here. So what this is here is a GG plot from ARM. It's facet wrapped. So in other words, each of those age groups that I described earlier on is describing it. And I'm doing a residual analysis. So I've taken my GLM. I've expected a certain amount of claims in each one of those triangles. I've actually compared it to my simulated data. And what you find is that you get these patterns. So with the older ages, we know we don't know, but we deliberately simulated it such that those older ages report earlier. And what we're finding is the residuals are positive in the first few columns, and then they come negative after that, which you see as blue followed by red. Similarly, around about 52, there's a sort of tipping point. And prior to 52, the younger people, just like my teenage son, a bit apathetic, don't bother doing anything for quite a while, they report later. So they're red followed by blue. Now, when you don't have a huge amount of data, that is a bit difficult to see. You do have to squint. But what I've done is that the next slide here, this is 5,000 claims counts. But if you had a lot bigger data set, that pattern will become more and more obvious. So if you combine the 1,000 simulations into one, then you get some really pretty and very obvious things. So you can see here from the data, you've got a very big and dark blue column coming through from the 60, 65-year-old, and it's very obvious from that point of view. So Now, I mean, we're not talking about the next stages where you would actually move it, but the idea here is if you had a chain ladder, it would be very difficult to get that sort of data. You might have to stratify it, and then so what, and then you end up with difficulties in data. But when you start moving into the new world, you can start using a generalized linear model or GAM models or GAMless or various other different statistical packages. But you can start to see the insights, and you can start to see this sort of residual analysis, and that will inspire you to move to the next model. So it becomes like you don't have to just sit in the same model. You can go, look at this model, see what it's showing you, what's the residual analysis showing you, what are the insights I'm missing from my current model, and then change it to get something different. The other thing is, and I must admit, when my team asked me this, we spent a lot of time building the generalized linear model cross-classification that gave you the exact result of the chain ladder. And I remember them asking me, why? What's the point? Why are we spending days building these two models when you know that they're going to give you exactly the same answer to 6 decimal places? And the answer is that GLM cross-classification can then be that springboard for doing other stuff that's interesting. So the first one here is we've talked about age as an important thing, and older people report younger than younger people. That's really important if you want to understand what your real age premium rate should be. Without understanding that, you will get a biased estimate of what your premium rate table should be by age. But perhaps more interestingly than age is notification period. So I've just come from the last session, and they were talking about different notifications speeding up or slowing down by notification period, not notification delay. You could bring that into your model as a third covariate. Rather than looking at it from a purely non-parametric point of view, so the GLM cross-classification is non-parametric, as is the chain ladder, you can start to smooth your parameter estimate and move away from 40 parameters in your model to something that's a little bit more parsimonious. And potentially look at a linear predictor or some sort of fitted transform linear predictor of the alphas to give you a slightly better smooth. And that's better than drawing a straight line through the data at the end. And then also you might move away from your purely non-parametric estimate of the betas to something that's semi-parametric, for example. I think, just wrapping up very quickly, we've got moving away from a model. And one of the things I've really enjoyed is as you start to get more models, you start to understand and get that granularity and start to move on to what your models, what next in your model sort of thing, you actually have that interesting dilemma of what model is the best? Which one, what insights it drives you? In the past, we've only had one model, so model selection has been pretty easy. It's the one model you've got. But as you start to move away from, and then the thing is, well, we've got one model. What are the parameters of the model? And as you move away from that and you start to embrace the data analytics journey, you then realize you've got multiple models that you can look at, and that it's actually about what model you choose rather than what parameters you choose that's interesting. Now, I think I'm going to have some well-deserved water at this point and pass over to my colleague in crime and give him back the button of glory.
Thanks, Francis. Francis is doing very well. So Francis texted me last night and said, I might have COVID, but he doesn't have COVID, as we know, because he's done 3 tests. But he's doing very well with his man flu. And a good whiz through some really cool pictures. So yes, they are good charts, but why should we invest in newer techniques? First thing, of course, is pricing accuracy, closely linked to a competitive advantage. We might end up with a lower price, which is justified, of course, from some insights which only we have discovered. Equally, we might spot a deteriorating trend, and we might save ourselves some grief. Extra granularity, we've been talking about quite a lot today, particularly in the last session, particularly where you've got changing business mix, which you certainly have at the moment within group insurance and superannuation, and anything where you've got external factors changing, like a pandemic or regulatory changes. Process efficiency and standardization are very closely linked. So there's still so much data wrangling and transformation that takes place in Excel, and it's very bespoke, really, for different funds. And so there's an awful lot there that can be standardized and automated. Changing mix and product design, we talked a little bit about, with group insurance, more voluntary in nature now. You've got shocks to your membership from PYS and PMIF. You've got your fund membership becoming more heterogeneous due to stapling of super. There's just an extraordinary amount of change in membership that's occurred over the last few years. In terms of objectivity, Francis showed you the age patterns there, the age notification delays for TPD. And there are many practitioners have known for some years that age is a big factor. In my view, it's driven more by cause of claim. I can remember, if I think back many years ago, around the time of what we now call the group risk crisis in Australia, stitching tens of thousands of claims together from different funds in Excel. And you can see quite clearly that there are some patterns, by cause of claim, by age. It was a bit of a kind of a eureka moment at the time, but in those days, using Excel, it's very unwieldy, and I think R provides a lot more potential statistical power, and hence, reduces some of the subjectivity involved. Risk management, it can give you, if you're implementing new models and techniques and processes, can give you good efficiency and standardization and reduce your operational risk, though of course there are some other pitfalls and risks to be aware of, which we'll cover in a sec. Enhanced visuals, whether using ggplot or rshiny, plotly, so lots of nice pictures to show people and sort of communicate the story. Like risk management, it can go either way in terms of communication. So obviously, if you've got the right graphics, you can tell a story, but it can be confusing for some stakeholders, if they're suddenly seeing a whole bunch of new charts for the first time. So maybe bear that in mind. And perhaps a little bit of thought then, so how we would do this. So let's say you've convinced your exec team, your general managers, whether you're an insurer, reinsurer, superannuation fund, you want to go for the extra granularity and insight. So how are we going to move models from sort of the old style to more kind of market leading? So I guess from the head of pricing perspective, you've got to set up your pricing governance to start with and be very clear on how you're going to do the whole project. You've got to be very careful about your process scope, how you engineer all the data and fit your models. You also can't really do this as BAU, we found. Particularly not in the group insurance market at the moment. We've seen lots of very wide-eyed, tired actuaries and analysts wandering around at the moment at the conference because they're working on big tenders. So you can't do it as BAU. You need a project team with dedicated resources. I really need a combination of skill sets. So obviously think about the skill sets that you have already in the team, whether you need extra help, etc. And really drawing and post the model build, that kind of training and development is crucial. Otherwise, you end up with lots of models that nobody can understand or change. That's really important. In terms of viability, your new models have got to fit with your current organization's systems and system stack, so that's very worthwhile bearing in mind too. Communication, of course, very important, helps to move people, I guess, in slow steps from things and techniques that they've been familiar with to more newer style techniques, sort of step by step. And you'd be very, very careful when you're explaining your insights that you have indeed found insights and it is not some new operational risk that you have not been aware of. Cognitive bias, very, very careful, particularly if we are in love with our model, Francis. You'd be very, very careful that we always sort of question the model and benchmark. Maybe moving down to the pricing actuary, I guess partly a decision on where you want to take your career in terms of, do you want to go the kind of complex technical route or the sort of managerial route? Some actuaries sort of make that decision sort of early on in their career. Risk management's very, very important. You can end up otherwise with a complex, hard-coded black box and even more mispricing risk. And think about the change management is some people are much more comfortable staying with the tools and techniques that they know, and that might be a little bit of a push to sort of take on new techniques and more training. Transition tools are important because ultimately once you launch your new models, you're going to have probably your old and new models in tandem, but you need to save time. So ultimately you've got to get rid of your old models and just sort of go with a new one. So it's well worth bearing in mind. Benchmarking, I think, is easier in principle, but you need to make sure that you do a lot of work on standardizing your data and fields between funds so you can sort of benchmark data and insights. So the training and development is very important. Training and development, it will save you time in the long term potentially, but you'll have more automation, but it'll be slower initially. So you've got to allow for people's different learning curves, etc. Did you want to talk about the actuarial?
I might just stay seated to keep my distance from you again. But from the actuarial analyst point of view, I think what I've found from doing a couple of these sort of exercises is that it's really super important that you see this almost as a change management process and it's at heart a people process rather than a system or stats process. From an actuarial analyst point of view, we're just trying to look at it from the 3 insights. From an actuarial analyst point of view, the first thing I would say is that it's a great opportunity from a career, the movement into the data analytics space and the merging of that sort of actuarial skill set and the data analytics skill set. So, choose which way you want your career to go, technical or managerial, etc. But take ownership of your career. This is a great opportunity for you to sort of drive your career forward at this point. And I think it would be good to make sure that you own your own training in that space. But also understand that as this is a change management process for you, your boss is going to be doing this for the first time, the head of pricing is doing it for the first time, the pricing stakeholders and clients are going to be doing this for the first time. So really understand what you as an analyst can bring to the party. And you've been doing quite a lot of the bulk of the actual sort of work. So one of the things that's going to be a challenge at this point in terms of the overall environment is that control is going to be a problem or an issue you need to face. So as an actuarial analyst, if you can show that you've got enhanced controls or you've done your own checking, that's going to be great in terms of your brand within the company. And also, as you move to new techniques, etc., there's going to be a need for training to move across. And if you're one of those analysts or senior analysts seen as helping out others in your team and training those, that again is going to be a big plus tick in terms of your performance management at the end of the year. And then just finally, just realize that whether it's the group pricing team that I manage, or whether it's a retail pricing team, or even a valuation team, or whatever, the new technologies, the new lines of thinking, all of these things are happening quite common. So some of the challenges we're seeing in terms of the modelling or these sort of change management stuff is common across a number of lines in business. And if you can sort of think of this as an opportunity to see yourself as part of a community and reach out to colleagues in other areas of your company and form that community, then you'll find that you can learn from their mistakes or their issues and vice versa. I think I'll pass you back.
Yeah. Thank you. So maybe just to summarize on some of the pitfalls, operational risk, we've talked a little bit about that. Don't create a black box. So consistency of model development and coding is very, very important, and that you have the right output in order to test your more complex models. So documentation is very important, which often gets left to the end of the process. And yeah, making sure you spend enough time standardizing your data and making sure that you have checks through your pipelines as well to make sure that the data in is consistent with the data out. You will have a bit of inefficiency in the short term. You might have to run multiple models in parallel, so that is well worth bearing in mind. Yeah, big testing overhead, and also making sure that you get the right outputs for people to be able to understand the models. Obviously, because you're working with new skill sets, you can introduce some key person risk in your teams. And also you need people who are able to review your code, whether it's R or SQL or Python. Not just doers, you need reviewers as well, potentially, to be able to review the code. Inadequate controls, we've already talked about a little bit. And yeah, making sure that you take your team along the journey and really sort of help them through not just your team, but the whole organization in terms of the change management piece. Yeah, and benchmarking, big fan of benchmarking. If you've got enough data in your organization and it's appropriately standardized, but then you can compare your assumptions for different funds and arrangements, and that can reduce your mispricing risk. So, I think it's now over to you, Kirsty. Yeah, we're going to have a little light-hearted vote.
I get to press the button as well.
Mm-hmm.
Are we just going to do a hand vote?
Yeah. Actually, we're going to do a quick for and against, aren't we? I think. Do you want to give your quick why we should do this?
Okay, I mean, you had me at pretty pictures, I think is the answer. But seriously, in terms of the commercial reasons, I mean, I would struggle these days doing some of the analytics or some of the pricing work I'm doing and not having these techniques. It makes me feel, I don't know how I could go back in time to 5 or 6 years ago and just try and stare into the tea leaves and try and work out what's happening without it. So I guess it's a bit like the remote control, whatever, you kind of, or your Siri, if you can try to tell your computer to turn it off or your TV, change channels. Imagine what you had to do when you had to go up and press the buttons on the TV. Why would you want to go back to that? That's my closing argument.
Okay, very good. So I'm going to play the part of the cynic, and I'm going to question the value of these newfangled techniques. I'm going to imagine I work for an organization that, where the increased overhead in skills and model development, heightened operational risk, extra challenges around change management, it's just going to be just way too stressful, at least in the short term. And maybe we've got concerns over data quality in this organization. We haven't got enough data sets yet to compare. So I'm going to be careful, and I'm going to say I want to stick to good old-fashioned actuarial judgment and a chain ladder and a blanket. And I'm going to stay there. And so common sense tells me that it's too soon for my hypothetical organization, as things stand, to move to my newest style.
I feel like, Matt, you're a little bit biased in your thinking.
Not at all. Not at all.
Okay, so just to wrap up, let's do a show of hands in the audience then. Whose organisation, who thinks the organisation is ready to implement these techniques in life insurance pricing? That's about half, do you think? And who's no? We might have a few sitting on the fence. Who doesn't think they're ready? We're ready. And there must be a few still sitting on the fence. Who's sitting on the fence? Okay. So I'd say we're about half yes, a few no's and a few sitting on the fence. Cool. Thanks very much, Francis and Matt. Just remind you that please feel free to use the app to submit any questions. We've got a bit of time left. We've got a few coming through already. I'll start with maybe a question, maybe for Francis. If you could have your time over, or if you're going to start this again, what would be the biggest lesson you've learned that you'd apply next time in your journey so far?
I think the important thing is to not throw the baby out with the bathwater too quickly. I mean, jokes aside, these models are fantastic, but also it's so easy to not understand them as well and sort of think you've got insight, etc. So I definitely think it's worth, at least to begin with, carrying on with some of the old techniques. It's so easy to get a beautiful bit of insight that gives you that competitive edge in a tender situation, but it's also easy to make a stupid mistake. And then not realise it and think it's, in your hubris, think it's some insight when actually it's some operational risk. So I think when you're doing these new models, don't give up on the existing models. Make sure that you understand that you reconcile each step of the way. You move in very small steps from the insights you're trying to model and build it up in little slices. I think that would be definitely the thing. I think I've really enjoyed this bit of the career where I've sort of learned new things. But I think if I was to go back to my my earlier self, I think it would be to avoid overconfidence and to make sure that you always check that the new models and the new insights you're getting do at least make sense compared to the old ones. There's an awful lot of good in what we've done as traditional actuaries, and I think throwing that away just because there's something new and shiny would be a mistake. So making sure that you do both, at least for a period of time when you think the operational risk is reasonable.
Thanks, Francis. What surprising things have you learned about claims behaviours by applying these techniques?
I might have a go at that one. So I can recall a model which one of my team built a little while ago, and it looked at, again, sort of different notification patterns, building a GLM. You have your different factors, but one factor is, is the claim pre or post protecting your super or, PMIF. And that in itself is a driver. So I think that's interesting, where you can look at your notification patterns, but also you can split between pre and post, and a good statistical way of showing that something is indeed different.
Okay. There's a great question here from
yeah, I might take that one.
You want to go as well?
I think, a couple of the key things in group pricing is obviously age, we've talked about here before, but another one is cause of claim. And I think Matt and I were having a good old age versus cause of claim debate about which one came first, the chicken or the egg. And I think a few years ago, before we saw these models, the assumption was that age and cause of claim were potentially proxies for each other, and that all old people like myself get cancer, and all young people have horrible motor vehicle accidents, and that's what's going on. But it turned out that actually they were only very partially correlated, and that age and cause of claim weren't actually that related when you actually looked at it, and that the cause of claim affected the notifications very early in the first year or two, and the age affected it more towards the back end, and that some of the things you might have presumed was the case didn't turn out to be. So it's actually quite nice to have this guess of as old hands what you think might be going on, and then you get your statistical model and realise that you weren't quite so smart in the first place after all.
Mm-hmm.
Okay. There's a whole heap of questions here we're not going to be able to get through, but there's a couple that have a lot of likes. So one great one from Jennifer. How do you avoid falling in love with the model and creating stories to explain non-existing insights?
Mm-hmm.
I don't know.
I can't really speak to falling in love with the model, maybe as much as you, but I think always benchmarking and always, if you can, compare with just common sense approaches and more simple models, I think, is always the way to go. I think you always got to bring it back to that. The thing is, though, if you think about old style models, think about chain ladder, the way that people often do chain ladder, there's loads of judgment involved. There's loads of smoothing and hand smoothing that goes on, and often it's not even brought out, right? I mean, you're doing your sign-off documentation and going through your various levels of approval. That might be missing, that one of your new actuarial analysts thought it was a good idea to kind of do a bit of smoothing in the top right-hand corner of the triangle. So at least with this, you have your models, you get them tested, more robust, you get them documented, and you can test things appropriately.
I've given it a lot of thought. I still don't understand the question.
I'm sure you do fall in love with your models, Francis. So from a more practical perspective, you mentioned that it's important you can't do this in BAU. You need resources, which resonates with me. About how long do you think you need to, or how much time, project team do you need to set aside to really get to that first level?
I think it gets quicker. The more projects you do, doesn't it? What's your?
I think the first time in terms of people years was probably 2 or 3 people years, and the next one was a couple of people years, and then I think you could probably get it down to a year. Mm-hmm. But in terms of so it's 4 people for 3 months sort of thing. Mm-hmm. But I think the key for me is that really bring in that diverse skill set. So it's actually quite a nice situation where you can come in with your actual skill set and insights, but somebody from a data analytics point of view can bring theirs. And if you listen to them, and I struggle with that a bit, and they listen to you, then you get it makes the project probably half the speed.
Okay, thanks. I thought the time would have gone now, but it hasn't yet, so I'll ask a couple more. This comes up, I think, a lot, is what are your drivers for choosing R over Python or SQL or vice versa?
This is like there isn't too much. We'll just choose one, I think, is the answer. So I think it's a bit like Betamax versus VHS. Now I'm really showing my age. I think going to data scenario, you get people argue it strongly either way. I think R is probably more widely known from people coming out of university, and that extra sort of use probably helps it from my point of view, but I really don't think it matters too much. Once you've learned one, I think the ability to learn the other one is quite easy. But it's not. I think use either is definitely my advocate rather than any particular one over the other. It's a bit like which one of my green car or blue car is better.
I thought you were going to say which one of your children you like better.
Well, that's easy, but I can't say.
I think with some organisations as well, it's there can be systems restrictions as well, and they might try and divert you towards R rather than Python. So I think that is something to consider, because it's got to integrate with your existing models and tech, but also it depends partly on what's the expertise in the team as well. So you might be better off sticking with something where you've got more people in the team that understand how to code in a particular language. So, yeah.
Okay. And just a follow-up, I think there's some interesting in the reporting delays by age group that you shared earlier. Are there any other findings around playing with the parameters of the model that you think are interesting to share?
Cause of claim, and then the other one would be things like whether or not the exposure is sort of eligible for, account balance and sort of active members, so whether or not they would still be members, historically if PMIF had been around since day one. And the interesting thing about these sort of statistical models is that when you have sort of missing data or data that's only partially there, so for maybe 5 or 6 years, you can actually extrapolate better. You can compare different cohorts of members for the data you do have and then extrapolate that back. So as you move away from sort of stratifying data into using regression models or other forms of models, you can then sort of extrapolate limited data into sort of a bigger picture and get a far better answer, and also sometimes a bit more of a competitive position.
Mm-hmm.
Okay, and I feel like I have to ask this last question to end on a light note. Is someone would like to know if there's a model, Francis, that you can build to avoid hitting your head on your car boots?
I'm still going for the rematch, so the boot door doesn't open fully and it should go to the top, and I use this to explain this to my wife. I said, what I need to do then is buy a new car, and she did explain to me that I perhaps could just replace the arm in the boot, which is a lot cheaper, but I still think I need a new car.
Too much complexity.
Well, I think
on last night, I do need to say that I'm not normally in a situation where I have sock envy. I went with because I was feeling quite nervous today, so I went in with the Border Collie socks on grey, which it's a calming sock, it's a bit of a comfort sock. But I do feel now, sitting on the sofa, that was a mistake, and that Matt just, again, happens quite often, is making me look small and ridiculous with the full-on purple socks.
Consulting socks, mate.
Yeah. So whilst I do have some regrets on modelling and my career and stuff like that, if someone had asked me the sock question, whose socks is coolest, I think I would have had to answer Matt's purple socks and won the day today.
good note to finish on. We're just about out of time. Thanks everyone for your attention today. I'll just remind you, if you could please rate the session on the app, and please join me in thanking Matt and Francis for their passionate, enthusiastic and insightful session.